Hello. Hi, my name is Travis, and I want to walk you through a new science paper today called What Can Lithics Tell Us About Hominin Technology's Primordial Soup, an origin of stone knapping via the emulation of Mother Nature. Essentially, this study is saying that there are natural rocks that form through natural processes that have sharp edges that early hominids may have been able to use to cut meat. And when they killed or had access to carcasses, they may have been able to use these natural rock tools to figure out how to cut the meat and access the bones and the marrow and stuff. And through that process, they realized, oh, these sharp edges are actually really valuable. Maybe I should make my own tools. So we have evidence of tool use, say 3 million years ago or so, 3.4 even, cut marks on bones and stuff. So we know that humans were or early ancestors were making rock tools then, but what we don't know is maybe humans were using this natural resource before then. So I'm going to walk through the video and just use my volume because my computer's too laggy. And yeah, enjoy. Thank you. Tell us about hominid technology's primordial soup, an origin of stone knapping via the emulation of Mother Nature. This came out, I think, a few days ago on April 14th. So let's read the abstract. The use of stone hammers to produce sharp stone flakes, knapping, is thought to represent a significant stage in hominin technological evolution because it facilitated the exploitation of novel resources, including meat obtained from medium to large-sized vertebrates. The invention of knapping may have occurred via an additive, i.e. cumulative process that combined several innovative stages. Here, we propose that one of these stages was the hominin use of naturaliths, which we define as naturally produced sharp stone fragments that could be used as cutting tools. Based on a review of the literature and our own research, we first suggest that the typical view, namely that sharp-edged stones are seldom produced by non-primate processes, is likely incorrect. Instead, naturalists can be and are being endlessly produced in a wide range of settings, and thus may occur on the landscape in far greater numbers than archaeologists currently understand or acknowledge. We then explore the potential role this naturalith prevalence may have played in the origin of hominin stone knapping. Our hypothesis suggests that the origin of knapping was not a eureka moment whereby hominins first made a sharp flake by intention or by accident and then sought something to cut, but instead was an emulative process by hominins aiming to reproduce the sharp tools furnished by Mother Nature and already in demand. We conclude with a discussion of several corollaries, our proposal prompts, and several avenues of future research that can support or question our proposal. All right, so that's the abstract. Let's read through it. Here's the email if you want to talk to the author. It's funded by various sources at Kent State University. And there's also some good images in here, the rocks, naturalists, and also a cool schematic of what humans might have been doing with these rocks. All right, so the deliberate knapping of sharp stone flakes is thought to represent the first instance of secondary technology. That is, the use of a tool to make another tool. Despite the impressive tool-using and tool-making capabilities of some non-human primates, including our closest living relatives within the genus Pan, no non-human animal uses tools to make other tools in the wild. Accordingly, the use of stone hammers to produce sharp stone flakes that are subsequently used as cutting tools is thought to represent a significant stage in hominin technological evolution, opening up the exploitation of novel resources, including meat obtained from medium to large-sized vertebrates. And you should recognize this Dominguez, Rodrigo, Pabiner, Thompson, Jessica Thompson. This in turn had profound consequences for hominin evolution, permitting an expansion of brain size. This is ALO and Wheeler's The Expensive Tissue Hypothesis, classic paper, and the eventual emergence of other technological products that required shaping through cutting actions. So I don't want to read the whole thing here, but it is a free article you can read. So they go through some examples of a bonobo chimpanzee that could make and use stone flakes in captivity. Let's see. In other words, the invention of knapping may have occurred via an additive process of combining several innovative stages, subsequently socially learned and built upon by others, or what some have referred to as cumulative culture or a ratcheting. Derricks recently proposed that one means by which the emergence of relatively complex technological behaviors may occur is through the exploitation and improvement of natural phenomena. As Derricks explains, natural phenomena are not created by individuals, they are simply features of our environment, yet they generate reliable effects that can be exploited and used for a purpose. Ultimately, human cumulative culture operates by exploiting an increasing range of natural phenomena. Okay, so archaeologists have long known that these naturalists can be created. These lithic forms are produced by natural geological, hydrological, and temperature-related processes and by non-primate animals. If these naturally produced stone fragments are shown to be tools or considered as potential tools, then we formally refer to this class of stone objects as sharp-edged naturalists. They go through, how they created this term. It's a brand new term to the literature. I guess other terms were pseudo-artifact, pseudomorph, nature fact, humanly unmodified rocks, and zoofact or geofact or eofact. But I do like the naturalith term. It's nice. And lith means rock, if you didn't know. So the goals of this manuscript are twofold. The first goal is to provide a limited review of the non-primate processes that can produce sharp-edged naturalists. Based on this review, we propose the naturalists can be and are being endlessly produced in a wide range of settings and thus may occur in the landscape in far greater numbers than archaeologists currently understand or acknowledge. This proposal leads directly to the second goal, which is to explore the potential role that naturalith prevalence may have played in the origin of hominin stone knapping. Alright, so this is naturalith production. So basically it's been going on for all time, and humans may have been able to find these stones. So we have compelling field-collected evidence that nature produces naturally sharp rocks coming from Antarctica. And the fun thing about Antarctica is that no humans were really there. So we don't think these rocks could have been created by humans. They must have been natural. So these various materials, chert, quartzite, hornfels, basalt, and obsidian. And they mimic a variety of technological forms: flakes, cores, biface forms, choppers. And then there's this, we'll have a figure one we can look at in a bit. Both Antarctic collections are broadly consistent with the hypothesis that nature produces sharp-edged stones in different contexts. Okay, and another way to make naturalists is trampling by large animals that can produce sharp-edged specimens. So they actually did a study where they had elephants walking over 4,300 pebbles and cobbles. Led by handlers, 2 elephants in tandem trot over the gravel a total of 50 times, with 2 feet of each elephant normally hitting the gravel pit per round. So the vast majority of the flakes were small, less than 1 centimeter, but they still identified 228 modified pebbles and cobbles, as well as 94 flakes larger than 1 centimeter. And, if you had thousands of elephants, big herds, moving over the landscape, maybe they did create a lot of sharp-edged specimens. There's also a bison trampling experiment, but it didn't work too well because they were skittish and wouldn't walk over it. But someone rolled around on the gravel pit, and that produced 34 modified pebbles and cobbles. So maybe these natural animal movements created sharp rocks, basically, that early humans could have found and then used to cut. So large-hoofed animals such as bison or elk might produce similar, perhaps even larger, pseudoflakes and modifications of boulders, cobbles, and flakes. All right. Here's another study that looked at how quartzite and flint might be modified when 3 donkeys and a mare did hoof trimming. And they found 15 complete flakes, some other type of rocks. So, alright, let's look at this picture. It's on the side, but we can see these are all from Antarctica, so definitely not human created, but just natural. You can see these sharp edges, maybe a sharp edge along there. This is probably obsidian. That looks like a nice hammer. You know, if you just look around rocks out in the world, like, you'll find cracks and sharp edges and stuff. So, you know, it does make a lot of sense. Like, if you find those in the environment, you're going to use them. So these are other ways we can create these naturaliths: soil movement, glaciation, wave action, high velocity water movement, gravity, rapid temperature changes, internal pressure, exfoliation, tectonic movements, diastrophism, and solifluction. Then we also have other natural forces: cliffs or waterfalls where rocks can drop, beaches with a violent zone of crashing waves, steep mountain ravines. And then there's some South African evidence: glacial action, fluvial glacial action. Okay. So many of these processes have been documented via field observation or demonstrated via experiment. And let's kind of move through this stuff. So here's some more examples. This is in Northern Ireland. It definitely looks like it there. And these rocks could have fallen down and then been sharp edges. Or these rocks fall down and hit the rock and crack. Or the waves are hitting them all in here and making sharp rocks. So here are some natural examples. You can see there's some nice cutting edges on these. Obviously, we didn't involve in Northern Ireland, but similar processes could have happened on the coast of Africa. Maybe in the Horn of Africa, where early human evolution might have been. So yeah, on the Homo Peninsula in Kenya, we have carbonatite volcanism and mechanical weathering as a result of an angular class of various rock types. All right, so that's important because Kenya is where we think early humans probably lived. So that would have been a natural spot for those rocks. Here's a dynamic quartzite coast near Pinnacle Point, South Africa. So down there on the shore, you know, maybe humans were looking for shellfish and washed up dead animals or something like that, whales. And they would find these rock tools and be like, oh, let's cut it into the whale and not use our fingers or teeth. So here are some more examples. These are all the same rock in different views. Or actually, that's the next one. But yeah, this is all in South Africa. Oh, here's a cool one. This is in Oman. Thousands and thousands of sharp flakes were produced via natural processes through these conchoidal and thermal fractured chert balls. I think they like get blown out of a volcano and they all end up here. Alright, so emulating Mother Nature may have generated the earliest stone knapping. Knapping is like breaking up the rocks and trying to make sharp pieces, but like doing it intentionally, not naturally. So here's another part where they're basically saying archaeologists and paleoanthropologists don't really consider that these naturalists could have been used, and they kind of just focus on the definitely human-made versions. But upon reflection, these typical views are not supported. Not only, as demonstrated in the previous section, are there a large number of natural processes that can produce naturalists, but some of these processes produce them in very large numbers, some of which can be refit. Okay, so naturalists definitely exist. Maybe they could have been used. So many scholars attribute the origin of stone knapping to a transferal of percussion from chimpanzee-like nut cracking or fruit smashing to stone. However, in recent years, a clearer picture of an association between the appearance of deliberately knapped assemblages dating to around 2.3 million years and older, and faunivory, which is like hunting of fauna or animals, is potentially beginning to emerge. And let's see, this is still an Oman, so let's see, that looks nice and sharp. Ooh, that's a gorgeous, nice little cutter. Not so nice examples in there. That could be like a hammer or something. So, so changes in behaviors relating to faunivory at this time are frequently thought essential to later events in human evolution, including the eventual emergence of larger brain sizes. This is not to imply that Oldowan tools were exclusively used for animal processing. Maybe they were used for processing animals and plants. The potential earlier existence of percussion behaviors directed at exploiting bone marrow and brain tissue from scavenged remains prior to and independent from flake stone use is also an important consideration given the eventual emergence of later patterns. Moreover, substantial costs in time, energy, and injury risks indicate the more substantial nutritional benefit of animal tissue processing would be more likely to motivate the emergence of deliberate knapping compared to the processing of vegetation. So basically they're saying vegetation isn't very nutritionally dense, and like apes are already like eating it, so why would they actually start using rocks to process vegetation? It's not like enough of a benefit. Whereas if they were processing meat, like wow, they get fat and protein, hugely highly dense nutrition, which could have led to evolution. So hence hypotheses proposing a link between chimpanzee-like percussive behaviors and the emergence of knapping currently do not address the potential transferal of percussive behavior from non-faunivorous behaviors in context to ones directly involving the processing of animal tissue. And here, these images are in Brazil. I got like this cool dune sedimentary layers. I guess they looked at this little path here, found some sharp stones, sharp. Oh yeah, these are the same stones, just different views. But yeah, that's a nice edge on there. Definitely sharp there. So, so accordingly, these people recently proposed that bone flakes created incidentally during archaeological documented percussive bone breaking for marrow extraction could have been the technological precursor to stone flakes. So let's look at this. Here's Western Kenya, the Homa Peninsula area. Some nice sharp rocks in here. Like, look at that one. So I guess these all fit together into one rock.
How much should we be?
All right, and given that there is an inevitable and immediate contextual and behavioral association between the smashing of long bones for marrow and the resultant product, i.e. bone flakes, this scenario is more behaviorally parsimonious than one that involves the transferal of percussive behavior from a context entirely devoid of meat processing, such as nut cracking. So they're saying, like, if apes were doing nut cracking, like, how would they then go into creating these stone tools right off the bat? Maybe there was like an intermediary process in there. All right, so the appearance of bone flakes within the context of faunivory narrows the distance between a problem, a need for cutting, and its solution, sharp bone flakes, to a greater extent than any other hypothesis, both in behavioral and cognitive terms. So instead of them like creating sharp bone flakes and then making cutting, they already had a need for cutting these animals, and they would have found naturalists to do that. All right, so here's the image that made me want to make this video, because it's just kind of great. So we have stage 1, cutting behavior appears. 1A, hominins break open bones for marrow, creating incidental bone flakes. Bone flakes recognized as useful sharp tools. Oh wow, I can use this sharp bone to cut more meat. And then cutting behavior begins, and bone flakes used for processing carcasses. Okay, so they like these bone flakes. They could use them more. And then naturalith use begins. So 2A, scavenging, butchering carcass in area near naturalists. So maybe a giraffe died near some rocks, and they were just happened to be butchering it with the bones. And then they're like, wow, actually this rock has a nice sharp edge. So they observe a naturalith utility for cutting. And then 2C, naturalith use spreads through hominin culture. Like, oh, you could use this, carry it around for the next carcass. And then stage 3, the emulation of naturalists. So hominins knock off stone anvils or stone flakes from an anvil, and or recognition of conchoidal structure or fracture to produce sharp stone flakes on demand. So they're like, oh, we found a carcass, let's make some new tools and copy like the naturalists that are all used up now. So stone tool production and use spreads through hominin culture. And then we get to like the more conventional science that all looks at stone tools. So this figure 10 is schematic of the origin of knapping. And we propose that naturalists could have acted as a crucial link between the use of bone flakes for meat cutting and the eventual emergence of the deliberate production of stone flakes via percussion. So hominins, guided by maximizing efficiency, could initially have been motivated to use incidentally produced bone flakes to complete cutting tasks during animal butchery, especially because, as we have noted, this scenario would be less cognitively demanding in terms of the characteristics involved in deliberate toolmaking, such as insight planning and foresight. So essentially, humans might not have been smart enough to make rocks on their own, and they needed like these naturalists to basically increase their meat intake and involve bigger brains, and then they were able to make their own rocks. So during one or more of these natural processing events, a carcass may have been present in the vicinity of naturalists. The likelihood of this is reinforced by the observation that early hominin food processing sites often occur near naturally occurring sources of stone, particularly in the early archaeological record. So either intentionally or by accident, hominin could have picked up, used one of these naturalists. And it has been noted via butchery experiments that bone flakes potentially produce fewer cut marks on bones. They're not as sharp or hard, and they produce shallower cut marks compared to those made when using stone flakes. So this suggests stone flakes are sharper than bone flakes and ultimately more efficient. You can use them longer and cut more things. So naturalist sharpness may have and likely did exceed that of bone, which would have provided impetus not only for the initial utilization of naturalists, but for hominids to seek them out, carry them across the landscape, and socially transmit their use to other hominids. Thus, bone percussive behaviors plus naturalist use would have provided two of the necessary ingredients for the conceptual origin of stone knapping. So I do some other comparative analysis of other apes. And so when framed in this way, the origin of knapping was not a eureka moment whereby hominids first made a sharp flake by intention or by accident and then saw something to cut, but instead was an emulative process by hominids aiming to reproduce the sharp tools furnished by Mother Nature and already in demand. All right, so let's see. So they're not suggesting these naturalists are ubiquitous or all over the place, maybe just in certain locations. But eventually humans would have the motivation to make their own rocks that are even better than the natural ones. So in this case, knapping helped hominins unrestrict their movements from natural sources of flakes to a new, broader resource distribution of natural sources of raw material appropriate for knapping. Another motivation for knapping may have to do with the number of hominids engaging with naturalists and cutting behaviors. If, for example, some naturalist sources only provide a small number of tools relative to the number of hominids who wish to use them, then knapping may have been a solution to provide sharp cutting edges to a greater number of individuals. A third motivation for knapping may be to combat edge degradation. Key demonstrated that blunting caused rapid reductions in stone tool edge performance. Hominins may have been motivated to solve this problem via the production of freshly knapped edges on demand. Finally, hominins could feasibly have learned over time to recognize that certain naturalist traits, size, mass, edge angle, or raw materials increase their efficiency during cutting tasks. Okay. Some other examples of chimpanzee here, or bonobo. Alright, so conclusions and future directions. The capacity to generate socially learned cultural patterns is deeply rooted within our great ape heritage, especially in terms of tool-related behaviors such as knapping. The eventual inception of knapping behaviors around 3.3 to 2.6 million years ago appears to have initiated a biocultural feedback loop between socially learned behaviors, increased faunivory, aka more carnivory, and the subsequent course of human evolution, including increases in brain size. And those increases could have helped them make better tools and also be better hunters. Okay, so here's some hypothesis testing that they suggest. I don't really think too many of these are that interesting. You can read them if you'd like. Okay. Longer-term biological implications of this behavioral shift in strategy, as well as the technological beginnings of a more plastic world in which virtually all human artifacts are cut, cannot be overstated. Okay, so that's the whole paper. Here's acknowledgements and funding. So I thought that was a cool study that kind of fills in a gap in our knowledge, like how did hominins first figure out how to use stone tools? And I think this little graphic here is pretty great. And this could fill in the gap. Maybe it's 4.5 million to 2 or 3 million years ago or so, the hominins were using these naturalists and then increasing their brain size and evolving and becoming more bipedal and stuff. And then they finally got smart enough to make their own tools. So I like this hypothesis a lot. I think it does help. It also helps push back kind of like the idea of carnivory and faunivory as a really useful trait over millions of years. And that leads us to further confidence that humans might be facultative carnivores, like really evolved to eat mostly meat diets. Maybe they did that for a really long time to get these larger brain sizes, and then they were able to use those cognitive skills to make their own rocks. All right, thanks for watching, and subscribe, hit that like, check out the link in the description, and I'll see you on the next one. For watching that, if you'd like to support me, I recently created an Etsy store, and I've got lots of carnivore seed oil type of shirts and mugs here. So I just wanted to show you some of these. I recently got this mug myself. I also got this shirt. I'm actually wearing it right now. Oh wait, oops. And there's a definition of nutrition on the back here. And we got stop eating seed oils. We have this nutrition shirt. I actually have all these now. Let's see. Yeah, so here's the back of the nutrition shirt. The practice principle of belief that modern humans are facultative carnivores, omnivores uniquely adapted to thrive long-term on animal-based ketogenic carnivore diets, composed exclusively of animal products, especially fatty red meat, while entirely eliminating plants, fruits, vegetables, nuts, carbohydrates, seed oils, ultra-processed foods, and fiber. With the etymology derived from meat and nutrition. So maybe one of these red ones. This nutrition one. This is my son turned into anime. Got one on no medicine was of any permanent advantage without the use of animal food. This is from 1797. Got a stop eating seed oils hat. I'm actually wearing it right now. You saw it in the beginning of the video. This nutrition shirt. Another nutrition shirt with some hunters and animals. Here's a fun one I thought of from the Garden of Eden. You've got carnivores and herbivores. We have a cyberpunk nutrition shirt. A similar one to this guy here. Here's the shirt with my son on him. Jurassic Park. And here's another Stop Eating Seed Oils hat. Stop Eating Seed Oils shirt. Stop Eating Seed Oils tank top. Carnivore Diet T-Rex. For all three of these. Stop Eating Seed Oils, just this big logo on the front. Here's a toddler's dinosaur hoodie. Nutrition facts. Subreddit. Here's my Stop Eating Seed Oil shirt. Here's one of my cats, Ray Ray. And these nutrition facts ones, which kind of talk about the carnivore diet. So yeah, thanks for checking that out, and I'll see you in the next video.